All right, guys, today we're going to take a look at some right triangle stuff. We're going to be looking at Pythagorean Theorem, which you may have seen before. So if this is not new, then hopefully this is just a nice refresher. If it is brand new, we're going to start with the basics, so don't worry. When we have a right triangle, the Pythagorean theorem says that the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other legs. Okay, so hypotenuse, of course, is across from the right angle. So in this picture over here on the right, C is our hypotenuse. It's across from the right angle. And then A and B are the other two legs. So Pythagorean theorem says that A squared plus B squared equals C squared. Okay. We're going to go through some examples. We are going to simplify these down. We are not going to have decimals, though. We're going to work this week with radicals and whole numbers. Okay. So knowing how to simplify radicals is probably going to be important. So if you struggle with that, that might be a skill you might want to go back and look back over as we work through our different types of right triangle stuff this week. For this first example, we want to solve for the hypotenuse. So that's already labeled as x. Okay. Remember, we said the hypotenuse squared. So x squared is equal to the sum of the legs squared. So one of the legs is 5 squared plus the other leg is 12 squared. Okay. Let's square those out. 5 squared is 25. 12 squared is 144. If we add those together, 25 plus 144 is 169, which is a perfect square. If we take the square root, then x is 13. Okay, so we solved for that missing hypotenuse length. That is 13. For example 2, we have a leg that is missing. Okay, so we're solving for a leg this time. Let's think about setting this up. We know that the hypotenuse squared is equal to the two legs squared and added together. So 7 squared plus squared. So notice that we can subtract. We can do 14 squared minus 7 squared. 14 squared minus 7 squared is going to give us x squared. So let's square those out. This is another reason why knowing squares can make things go faster. 14 squared is 196 minus 7 squared, which is 49. Okay, so that's going to be equal to x squared. So if we do 196 minus 49, that's going to give us 147. Okay, you may remember this one from when we did simplifying radicals. This was one where we had to solve. We want to take the square root of 147. So let's think about breaking that down. Okay, 147 is actually 49 times 3. Square root of 49, of course, is 7. And so we'll leave the 3 inside the square root. So when we take the square root of 147, we could reduce that to 7 square roots of 3. Okay, relying on radical skills that we learned back in a prior unit. All right, there's one other term listed down here at the bottom. This is a Pythagorean triple. A Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfy the equation a squared plus b squared plus c squared. So what we want to think about is anytime they refer to a Pythagorean triple, you basically just need to know what it's talking about. They may ask you which of them are a Pythagorean triple. Look back at our examples. For example 1, we solved and we found this missing piece to be 13. So we have 5, 12, and 13. Those are all 3 positive integers. Okay, so they're 3 positive integers. That means this is a Pythagorean triple. Okay, example 2, however, when we solved for x, we had 7 square roots of 3, right? So we had one number that's not a positive integer. 7 square roots of 3 is not a positive integer. Okay, so this is not a Pythagorean triple. Okay, and again, that's just terminology thing. If they ask you if it's a triple or not, you just need to know you don't want to have a decimal or a radical for any of your side lengths. Okay, otherwise it's not going to be a triple. Okay, we're going to do the same thing here. We're going to solve for missing pieces, and then we are going to decide whether it's a Pythagorean triple. Okay, so let's take a look here. For A, we're solving for x, which is one of the sides, one of the legs. So we could set up 8 squared is our hypotenuse, minus 4 squared, which is one of our sides, equals x squared, our other side. So 8 squared is 64, minus 4 squared, which is 16. 64 minus 16 gives us 48. Now we want to take the square root. We have done this one before in our prior unit. Square root of 48, remember 48 is 16 times 3. So if we want to reduce that, square root of 16 is 4, and the 3 would stay inside. So 4 squared to 3 is x. So this one is not a triple because 4 squared to 3 has a radical. It's not a positive integer. All right, let's try the next one. We want to solve for this missing leg of the triangle. So we could take 16 squared, the hypotenuse, minus 8 squared, our other leg, equals x squared, the one we're solving for. Now, again, this is where knowing our squares can come in helpful. 16 squared is 256, minus 8 squared, which is 64. That's equal to our x squared. So if we divide 200, or not divide, excuse me, if we subtract 256 minus 64 leaves 192. Okay, that's our x squared. Now we want to take the square root. Square root of 192. Okay, what we need to realize is that 192 is equal to 64 times 3. Square root of 64, of course, is 8, and then the 3 would be left inside. So x is 8 square roots of 3. And this one is also not a triple because we have the radical for the one we solved for. So both of these, we ended up with a radical for one of the lengths, so those are not triples. All right, let's take a look at last one here. We're solving for a leg again. So we could take 89 squared minus 39 squared equals x squared. These I wouldn't necessarily expect you to know. 89 squared is a big old 7,921. 39 squared is 1,521. That's going to equal x squared. Okay, so now we want to subtract 7,921 minus 1,521 is going to equal 6,400. So that's x squared. Take the square root and we are going to get 80 for x. Okay, now notice on this one, our 3 side lengths are 89, 39, and 80. All our 3 are positive integers. So this one is a Pythagorean triple. Okay, that was the only one of these 3 where we got a Pythagorean triple. All right, let's take a look a little bit more difficult. So we're moving along. We're doing something a little bit more difficult this time. For part A, we want to find the value of x. The problem is that we have 2 right triangles. So we actually have to find the hypotenuse in this bottom triangle, which is then a leg of the top triangle in order to get around to find x. So I'm going to call this piece y. Okay, so I'm going to call it hypotenuse y. Well, the hypotenuse of the bottom triangle. Okay, let's solve for that first. We know that 1 squared, whoops, not equals. 1 squared plus 3 squared equals y squared, right? So 1 squared is 1, 3 squared is 9. So now we know that 10 is y squared. So square root of 10 is y. We can't break that down anymore. So now we know that this piece is square root of 10, which is a leg in the top triangle. We want to solve for x. We have 2 of the legs. X is the hypotenuse. So we want square root of 10 squared plus 1 squared equals x squared. Okay, let's square these terms. The square root of 10 squared becomes 10. 1 squared is 1. 10 plus 1 is 11 is our x squared. So if we take the square root, x is just square root of 11. Cannot break that down anymore. So we found our x. We got square root of 11. Okay, so we just had to do Pythagorean theorem twice. Okay, we had to solve for the hypotenuse in the bottom triangle, which was then a leg of the top triangle, so we could solve for x. Take a look at B. The difference with B is that we have two x's. Both of our legs are marked x. So think about setting this one up. Leg squared plus the leg squared equals the hypotenuse squared. So x squared plus x squared equals 4 squared. Let's combine our like terms. X squared plus x squared is 2x squared. 4 squared is 16. Now if we want to solve for x, we divide by 2. So x squared equals 8. Okay, when we take the square root, 8 is 4 times 2. So square root of 4, we can bring that out as 2, and there's a 2 left inside. So x would be 2 square roots of 2 for both of these pieces. Okay, and remember, you could always plug back in the Pythagorean theorem and make sure they work when you solve and get your answers. And again, we are relying heavily on our radicals knowledge and simplifying radicals that we did in our prior unit. All right, we're going to take it up another notch, and we're going to take a look at some applications. They give us some information here, so let's start working through. Given that WX is 7, okay, YZ is 13, ZW is 8, okay, and now we want to find perimeter and area, okay. So let's talk through a few things, okay. We could draw a line down, and now we have a rectangle and a triangle together to make this trapezoid, okay. We would know that this piece would be 8, this piece would be 7, which if this whole thing from Z to Y is 13, and we already know that this piece on the left is 7, that leaves 6 for the bottom of the triangle. In order to get the perimeter, we have most of the pieces. The last piece we need is XY. I'm going to call that, let's use a different variable. Let's just call that C since it's a hypotenuse. Okay, so let's solve for that. Looking at that right triangle, we have 8 and 6 as two of our legs. So we could say 8 squared plus 6 squared equals C squared. 8 squared is 64. 6 squared is 36. If we add those together, we get 100. Take the square root, and now we know that C is equal to 10. Okay, so now we know that piece is 10. Now we have all the different pieces, and we should be able to solve everything. Perimeter of the I'm adding up all the sides. So think about our sides are 8, 7, 10, and 13. So if we were to add up all of those numbers, we should end up with 38 as our perimeter. So the perimeter of that trapezoid is 38 units. Then we want to find area. Okay, so there are two ways that we can find area, and I'm going to actually go through both of them with you. Okay, the first way is if we know the area formula for a trapezoid. Area formula for a trapezoid is 1/2 times the height times base 1 plus base 2, so the sum of the bases. So let's think about here. 1/2 times the height. The height of the trapezoid is 8. One of the bases is 7, and the other base is 13. So I'm going to go ahead and do the 1/2 times 8. 1/2 times 8 is 4. Okay. And then 7 plus 13 is 20. 4 times 20 gives us 80 for the area. Okay. Now that's one way we could do that. If we don't remember that formula, then we can still use the fact that this trapezoid is made up of a rectangle and a triangle. So let's add those two together. Okay. We're going to add the rectangle plus the triangle. So area of the rectangle is base times height, so that would be 7 times 8, plus area of a triangle is 1/2 times base times height. The base of the triangle is 6, the height of the triangle is 8. So now let's go through and multiply. 7 times 8 gives us 56. Okay, 1/2 times 6 is 3, times 8 is 24. 56 plus 24 gives us 80. Okay, so either way, we end up with 80 for that area, no matter which way we do it, whether we find using area of a trapezoid formula or whether we add the rectangle plus the triangle. Okay, either way is fine and either way works. A lot of times it's just whichever one you see first. All right, we're going to do some more area. For these two, we want to find the area of these figures. We have to use Pythagorean theorem in order to find a different length, though, so that we can find the area. The first one, for A, we need this other leg of the right triangle because that would actually be the height of our triangle. So we can set up Pythagorean theorem. Okay, let's set it up. If we have, we'll call this x. Let's say this is x. So x squared equals hypotenuse squared minus the other leg squared. Okay, we want to make sure that we square out our terms. 12 squared is 144. Okay, 9 squared is 81. Now we want to take 144 and we want to subtract 81, which would leave 63. So x squared is 63. Now we want to take the square root. Let's think about simplifying square root of 63. 63 is 9 times 7. So if we take out the square root of 9 is 3 and we leave a 7 inside, we now know that this side up here is 3 squared, so 7. Okay, area formula. Area of a triangle is 1/2 times the base times the height. So 1/2 times 9 times 3 square roots of 7. Okay, let's think about here. None of these is divisible by 2, so we're going to leave a 2 on the bottom. 9 times 3 is 27, so 27 square roots of 7 all over 2. So our area, 27 square roots of 7 all over 2. Okay. Oh, and we do have units, so this would be centimeters squared. Okay. Part B, we are given quite a bit, but we don't know the height. Whoops, that's a little jagged, but pretend that's straight. We don't know the height of this trapezoid, or again, you can break it into a triangle and a rectangle. So let's think about some things that we do know. If this entire thing is 16, okay, and this piece is 10, then that means this bottom piece of the triangle has to be 6. We've actually already solved one like this in the reverse. We had 6 as a leg and 8 as a leg and found 10 as our hypotenuse. We could set up Pythagorean theorem if we needed to. If we don't remember that, let's call this, we'll call it x again. So x squared should equal 10 squared minus 6 squared. So x squared equals 100 minus 36. So x squared equals 64. Take the square root and x has to be 8. So we know that this piece is 8. Now we have two options. We can go through and either find area of the triangle plus area of the rectangle, or we can do area of a trapezoid. I'm just going to go ahead and do area of the trapezoid all at once. 1/2 times the height times the bases added together. So let's plug that in. 1/2 times the height, which is 8, times the bases added together, 10 plus 16. 1/2 times 8 gives us 4, and then 10 plus 16 is 26. 4 times 26 is going to give us 104. So our area for this one is 104 centimeters squared. Okay, and again, we could do the triangle plus the rectangle. I'll go ahead and do that really quick just to make sure you see that we can get the same thing. Let's go ahead and multiply rectangle plus the triangle. Okay, so rectangle would be 10 times 10, it's actually a square, plus, excuse me. The rectangle would be 10 times 8. So it's not a square, it's a rectangle. Plus the triangle, which would be 1/2 times base times height. The base of the triangle is 6, the height is 8. So 10 times 8 is 80. 1/2 times 6 is 3, times 8 is 24, and 80 plus 24 gives us 104. So either way, we get 104. Okay? So again, doesn't matter which formula you use for an area of a trapezoid. You can add your triangles together if you have a triangle and a rectangle. Sometimes you may have two triangles that you have to solve for, depending on the shape of the trapezoid. But you can always just add those separate pieces together to get the total area if you need to. Okay? Or if you memorize the trapezoid area formula, it can be a little bit faster, just plugging straight into that.